coming. My name is Bruce Momjian. I am one of the Postgres core team members. I've been with Postgres since 1996, and I've been with Enterprise DB since 2006. So I've seen a lot. My website is right here. In case you're looking for a copy of these slides or a video, there's 58 presentations and 98 videos or something like some crazy number. So again, wealth of information. QR code does work, people say. So maybe you have to get closer, but it does kind of take you to that website. I am really excited about giving this talk today. I always like this talk. I don't know. This was started as a series of blog entries because I was just baffled by nulls. You know, there's this very quixotic behavior of nulls, and it was a series of 10 blog entries on my website. In fact, I have 650 blog entries, so well categorized. So if there's a topic, I probably discussed it. Nulls is one of them. But once I wrote the blog entry, I said, you know, I really should kind of bring this together. It feels like it kind of gelled, and I made this presentation out of it. So I hope you enjoy it. I'm glad to take questions at any time. There's really no sections here. I don't want to say it's a stream of consciousness, but it's sort of a journey through the null landscape. And hopefully from here you're going to get a sense of how nulls behave, where nulls can get you in trouble, and then sort of how to wrestle nulls into behavior that's acceptable to you. I don't know how many of you are application developers. I was an application developer in the 90s. There was a whole bunch of cases where nulls bit us. We're like, why isn't this query? It's like it's got the wrong total. I know there's this amount in the accounts, but when I run this query, I don't get the same number. Why is that? And often the culprit was nulls. So I'll highlight that as I go to kind of give you a sort of places to watch out for. Nulls are incredibly powerful. They're also unavoidable, and they can easily get you in trouble. So hopefully from this talk you're going to come out a little better prepared. Okay. Any questions? Okay. So null. Well, null in English means nothing, but you get philosophical. Is nothing something, right? It's sort of a weird concept. But in computer science, null typically means undefined, and you see that in C. You see it in a variety of languages where if you haven't defined a value for something, it just becomes null, which usually works. But in the data space, nulls can be kind of complicated. For example, what value do you place in a field if it doesn't have a value? If you don't have nulls, well, if it's a string, that's kind of easy. A zero-length string is kind of a good null, right? Like, okay, there's no string length, so it's a null, right? But for numeric types, for example, what value? Because you don't really have a zero-length string for nulls. And then you start to get into the magic value like -1, -99. I don't know how many of you have seen these kind of numbers. Everyone uses a different number in the same application, right? Because there's no predefined, without a null, there's no predefined really idea of what to put for an undefined value. So you hopefully as an organization pick one and keep it consistent, but it doesn't work out that way a lot of times. Same thing with dates. There are a couple of famous databases that have weird dates for nulls. Postgres fortunately never went there, but you can imagine a date has a similar problem. So we've got the concept of nulls. It's in the SQL standard. It's well supported in Postgres. And again, what I'm going to talk about here is related to Postgres, but it relates to all the other relational databases too. Yeah, there's some specific Postgres things in here, but in general, you should be able to get a lot out of this. One of the problems right away for null is it has three purposes, and that is a serious problem. Anything that has three different purposes and they all look the same, you kind of get into trouble. In fact, there was I think one of the SQL standards people actually was thinking we should have three different nulls to represent these three ideas. Now, never went anywhere, but you can kind of see a little bit of the logic of why you might want to do that. The first one is for unknown values. So that would be a use for a null. Second one would be for an inapplicable value. You know, it's not that you don't know it, it just doesn't apply, right? And the third one is like an empty placeholder. And let me give you some examples of that. So let's suppose we have an employee spouse column. I think this is like the clearest one for me, right? So if you put a null in the employee spouse column, does that mean we don't know the spouse's name, right? The person hasn't reported it. The employee's not married, and therefore there's no spouse, right? Not applicable would be a representation of that. Or we're doing a join with the employee table, and the spouse column's not joined. So it's just null, right? So even if you decide as an organization we're never going to let nulls in our system, you still by outer joins can get nulls, right? So this is sort of the problem. I think that avoiding them completely is not a realistic solution. You really have to kind of, buckle down and take it on. And hopefully, as I show you some of the gotchas, if you can keep those gotchas in your head, that'll get you 90% of the way there. So, as I said before, nulls can cause their own problems. Don't use them in inappropriate situations. They have there's a what is it? Biblical verse that says, every day has enough trouble of its own, right? Don't worry about tomorrow. Every null has enough trouble of its own. Don't add more of them if you don't have to, because it can be a very, very complicated place to be. I love this quote. It's by Joe Selko out of Austin, big Postgres fan, and he's writing about another book that mentioned nulls. C.J. Date, obviously, most people recognize that name. And basically, the idea here is that nulls are more trouble than they're worth, and they should be avoided. They're strange. They're inconsistent behavior. Source of error, confusion. Very true. And he basically says try to avoid using nulls, but then if you have to, use them judiciously. And I think this is a wise approach. You just can't use SQL without at least understanding some of the traps that nulls can put you into. So there's going to be a lot of text here. So if anything you see in red, that was what you should be looking at, because you'll see a lot of text on the screen. And again, something's red, like the fingernails, you kind of look at them right away. So here you can see the red right here. So what I'm going to show you is I'm going to start really slow, and then I'm going to work up into weird. Okay, so we're going there. Any questions? Okay. First thing, select null. Perfect. But by default, PSQL just reports nothing. And that can be quite confusing because nothing is hard to identify from a zero-length string or from no rows at all, right? I mean, you can see the confusion there. So one thing I did for this test is I actually did a p set, and I made null equal to that string right there. So now if I do a select null, I get something that I can see. So again, this is for illustration. If you haven't done that and you run these in PSQL, you will see different results. So be careful. So how do nulls get into your system? The first way you get them into your system is to effectively, literally insert them. So here's an example. I'm inserting a null into the second column. And as you can see, when I do a select, I get my null back. Right? Pretty straightforward. Here is another way that nulls get into your system, but here we're doing it implicitly. And how are we doing that? We're specifying only one of the two columns from the null test table. So remember back here, I said there's an X and a Y column, right? So here I'm just inserting into the X column. So what you see here is by not specifying the Y column, I implicitly inserted a null into that field, right? Here's another way that nulls can get into your database. You can block nulls, and I do recommend this. Frankly, I have a blog entry about it. Normally when people are creating tables, they think, okay, column name, data type. Column name, data type, column name, data type, right? That's usually the way I type my create table statement. One of the things that I recommend for people is think of it as column name, data type, constraint. Column name, data type, constraint. Okay, and the reason for that is you're losing a lot of the power of SQL if you are constraining columns that shouldn't be null, columns that you should be unique, columns that maybe you should have a check constraint with a pattern, right? There's a whole bunch of foreign key references. There's a whole bunch of things that we can do with constraints that really increase the power of relational systems. And if you're not using that, you're kind of getting only part of the rich relational experience. I can't believe I just used that word, but anyway, I think it's actually true. So if you take a look up here, I created another null test table, and what I did was I added constraints not null and not null. Now, this might be the username. You don't want the username to be null. This might be the user ID. You don't want that to be null. There's a whole bunch of reasons that you might want to do that. Now, sometimes it's implicit. If you use primary key, that is unique and not null on its own. It's like a package. It comes with primary key. But if you're not doing that, then every column you don't want to be null, you should really say, I don't want a null here. Remember, I'm talking about how to avoid some problems. Problems not only from SQL, but problems when applications misbehave. They forgot there's a new column and they don't insert into it, right? You want to see these errors early on rather than collecting a bunch of garbage data and having to go back and clean it up. Because I used to have to clean up that data, and it wasn't fun. Typically, at the end of the month, we had to do the data cleanup. I don't know if anybody else has experience. So, for example, if I insert in a null test 2 and I use a literal null, I get an error. Violates non-null constraint. If I do an implicit null in the final one, again, violates non-null constraint. So, just keep aware of that. Okay. So that's kind of the basis of where we want to go. Now I'm going to show you some of the behaviors that hopefully will give you a pattern of where we're going here. So if I add 1 to a null, I get a null, right? And that actually kind of makes sense. It's an unknown value, or it's a non-applicable value, or it's a value of an outer join, right, that doesn't exist. So adding 1 to it doesn't make any sense. Concatenating it doesn't make any sense. No matter which order you do it in, you get nothing out. And there's many cases when we wrote applications. Remember I was talking about guarding fields that shouldn't be null. If you're concatenating columns together and one of them's null, all of a sudden you're like, why does my report have this blank there, right? And then I'm the guy who has to go in there and figure out why. How did that data get in there? And then what application is not filling that data in? And right, you can see why it gets to be confusing. So again, a lot of the data sanity would say not to allow null if you're going to be concatenating certain columns together. Null is basically an unknown value in a way. So here I'm inserting. I'm going to show you some of the values into an increment test. So 30, 40, and null. And as you can see, x plus 1, if x is null, then you get null out. Remember, we just showed you that in the previous slide, right? That makes sense. Now, for comparisons, it gets a little tricky because unlike the C language and most languages that we work in, that I work in at least, there's usually a true and false kind of a understanding of comparisons. Either a value is true or it's false. It's non-zero or it's 0 or it's t or whatever. There's always usually some kind of true-false dichotomy there when you do a comparison. SQL doesn't have that. They have what they call a 3-valued logic, which means that a comparison can return true, can return false, or can return null. And there's some ways around that I'll show you in a minute. But effectively, when you're logically thinking about, okay, either it's false or it's true, that's where you're going to get into trouble. And I'll show you some queries where we sort of come at that, oh, either this is true or that's true. No, because there's this third value that can pop up and cause all sorts of problems. So, for example, if you compare null to 1, which seems logical, it returns null. It doesn't return false because it's an unknown value. So it may be 1. We don't know, right? So again, this unknown concept comes across. Does it equal a zero-length string? We don't know. Does a null equal another null? Right? No, we don't know. We don't know if it knows. Maybe they do equal. We don't know. They could have come from 2 different places. Even if they came from the same place, the answer is still null. And this is where you start as an application developer, you start to get confused. You're like, well, logically, if I compare one null column with itself, they're both null, but they're both the same value. No, it doesn't think that way. It's not a thinking thing. If you compare it, it's not. Even this last one, which I love, is null less than null plus 1. Well, you know, no matter what value null has, that's going to be true. But no, we're going to call null here. Okay. So again, this is one of the tricky things you start to get into. Null can represent unknown, non-applicable, or unassigned. So you imagine non-applicable, a non-applicable value. If you increment it by 1, it's still non-applicable, right? So maybe that's the way it should be. So this is the problem. There isn't a one-to-one mapping between unknown, non-applicable, unassigned, and the behavior that you see. That's the primary problem here. So again, that's kind of interesting. In queries, it gets interesting. So if select 1 where it's true, you get a 1, right? But select 1 where a false, whatever that false would be, you get nothing. But if you select 1 where null, you also get nothing. You don't get a null rule, you get nothing. Okay, so really the where clause only returns true results, not non-false results. See what I'm saying? Like non-false is not always true in at least the way we think of it, because a not false could also be a null, right? Right, because there's 3 possible values for that conditional expression. So if I say it's not false, you're like, oh, it must be true. No, it could be a null value too. Right, it's kind of really interesting. Null is not false either. So if I say true and null, I get null because it doesn't know. It could be true. It could be not. We don't know. So it's null. Not null is actually null, which I don't even know where to go with that. It's saying that is something so it's taking a null and it's knotting it, right? And it's reversing it, but it's still a null. You know how you say like not x equals 1, like it's not x equals 1, right? But this is not null, so it's not. This is not is null. This is not null. It just doesn't know, so it doesn't reverse out with the thing. Any questions aside from head hurting? Okay, yeah, I know. It's we're only on slide 18, so yeah, we have a lot more to go, and it gets weirder. So yeah, that's why I like this deck, because it's just your head is just, I don't know, like wow, like I just don't want to. I don't want to shut my eyes at night, kind of thing. So this is one area that really got me when I was an application programmer, and I can't tell you how many times we'd be like, I don't understand, like these numbers don't add up, right? I used to work for, I used to write financial applications for law firms, so we'd have to end the close each month and reconcile the reports, and they would say, why doesn't this add up? And I'm like, I don't know. And I'd have to figure out why, and that usually, a lot of times, the null was the base of the problem, and my misunderstanding of nulls at that time. So we're back to the ink test table. We have 30, 40, and null, right? So this is where your brain kind of starts to kind of fall over, right? So you do, okay, I'm going to take all the values greater than or equal to 0, and I'm going to put them over here, and I'm going to put all the values less than 0 over here, right? Simple. I got all my values, right? Either they're over here or they're over here. What do you see on the, what's this? All your known values, exactly. Because if you look, I got 3 rows here, right? Thank you so much. Got 3 rows at the top. All the ones that are greater than 0 are 2 rows, right? How many rows are less than 0? None. Right here. No values less than 0. Ooh. Even if I do this crazy thing, you look at that as your programmer, you're like, it's got to be everything, right? No, it isn't. And this is some of the quicksand that you can get into. That only returns the non-null values. Yeah. So you have to actually, as you're writing queries, if you expect nulls to be in there, you actually have to be proactive about what you want to do with the null values in that table. Because if you don't, you're gonna end up in trouble like this. Another kind of example, not equal to 10. That's another great one. So how many rows don't equal 10? 2 rows. And the last one is crazy. How many rows either equal 10 or they don't equal 10? Right? You would think that would be all your rows. Some of these mistakes my colleagues made, so I have to admit I didn't make all the mistakes. Some of them, the guy would bring me in. He's like, Bruce, this query doesn't return the right number. And I'd be like, okay, walk me through this, and we'd eventually figure out why that was happening. And he made some kind of assumption like this, right? Like either the person's in Pennsylvania, they're not in Pennsylvania, and we're doing a report, right, for taxation maybe. But the two numbers don't add up to the grand total of all the customers. How can that be? Well, it's because we've got null states in there, and nobody had a not null designation on there, so we got a couple null states. And now we have to scramble around to find the person who entered the data. Where is that customer? I don't remember. I put him in, and it was 6 months ago, and let me look him up. And yeah, you're in for a world of hurt, right? And not null would have fixed that, honestly. Not in. If you thought that not in is just its own problem. Because a lot of people, when they think of not in, they think of it as a sort of a set operation. They're like, okay, is it in this set or is it not in this set, right? That's kind of what not in is. So, like you would say at the top, you say, is 1 not equal to 2 or 1 not equal to 3? Well, that's pretty easy. That's true, right? But then if I say, is 1 not equal to 2, 1 not equal to 3, and is 1 not equal to null, that's null. Because we don't know if it's not equal to null. We don't know if it's equal to null, right? Which is pretty clear. That I can get through my head. But we don't know it's not equal to null. Right? So then I have to say I don't know. And I'm going to show you some queries in a minute where we do in clauses, and all of a sudden you do a not in and you don't get any results back. You're like, what happened? Like, I'm not getting any. There's like, I should get something. Right, and that's usually indication that there's a null in the subquery that you didn't expect. So here's probably the canonical example. Is A in null? Right, so is A in a set of nulls? And the answer is we don't know, obviously. And then is A not in a set of nulls? And we also don't know that. Okay, so that one I can kind of see because I can see the null right there. Right. But when you start to do this kind of thing, it gets a little more confusing. So here we're saying, is A in A or null? True, right? Everyone good with this? Any questions? Okay. So is A in A or null? Well, it's in there. We know it. We're good. We're great. Okay. But then the next one is harder. Is A not in A or null? Well, it's not. We know that's false because we know it's there, right? So we know that it's saying, is it not in A? And we can see the A right there. So we know for sure it's not there. Even though there's another null there, we don't care because we've stopped as soon as we see there's a match, right? But the next two is where everything kind of falls apart. So is A in B? Well, yeah, A is not in B, so we're good so far. Let's go to the next one. Is A not in null? I don't know. I return a not null, null, right? And the last one is A not in a B. Yes, A is not in the B. Is A not in a null? We don't know. 3-valued logic, it returns a null, and we don't know if it's not in there. So you may have a whole bunch of values here, and as soon as you have a null in there, that not in becomes I don't know. And then because the where clause doesn't return anything that is non-true, meaning false or null, it doesn't return false and it doesn't return null, then you don't get any rows. And this was a very common cause of problems. In queries, we can expand these a little bit. So is A equal to B, or is A equal to null? Well, again, we know A isn't equal to B. That's true. But it's this is where it gets kind of confusing. So A equals B, we know that's false, right? And usually, so the bottom line, it's false. So we have to keep going with an OR. Remember, with an OR, as soon as we hit a true, we're done, right? But if we hit a false, we got to keep going. So if A equals B, that's false. Or is A equal null? We don't know. So we don't return false. We return I don't know, right? And similar at the bottom, is A not equal to B? That's true, right? But again, remember with AND, you have to keep going through all of them as long as it's true. Remember, as soon as it hits false, you know you're false. So is A not equal to B? That's true. Is A not equal to null? I don't know. And then return null. Okay. So that's why the not inquiries are often problematic, because you have that sort of behavior there where it continues going. As soon as it hits a null, everything just falls apart. Even though you kind of know it's not equal to any of them, but there's this null in there, and then you kind of, that's where I'll show you a little later how to fix that. And here it is. So first, how do you compare nulls? This is how we're going to get out of our problem here. So does a null equal a null? Again, we saw before, we don't know, right? It returns null. But the powerful use is the is null clause. Okay, so a null is null. That is true. That's the way you compare for a null. You don't compare it to zero-length string. You don't compare it to another null. A lot of people are saying, and this looks really clear, but where you see the people get stuck is they'll say where column not equal to null or where column equals null. Doesn't work. We just saw right here, a null doesn't equal a null. It doesn't know. So you get caught up in a lot of that where people will say column equals null and whatever, and you'll be like, duh, that doesn't work. Or if you're comparing two columns and one of them's null, it doesn't work either. So that's why there's this special is null construct and is not null construct. So where you can specifically, not with an equal comparison, but with an is comparison, to say null equals null. Yes, null is not null. Remember, this is the negation of null, and that's false. Right? We're getting actually real values here. Okay, so is null, is not null are actually canonical ways of doing this. So when we talked about doing subqueries and having these nulls come into these in clauses and not in clauses, 80% of the time, the fix was to add a clause and the column is not null. Because in a lot of cases, when we were checking for group membership in a table, in a query, which potentially could return some null values, we basically didn't want the nulls to be considered in that case. And as long as we, in that subquery, said is not null, column is not null, the problem went away. We got results that matched, and everything was good. But you have to remember to do that. You have to remember that the nulls are possibly here. And if you don't, then you get caught up, and then you have to go like pepper your queries with a lot of not null, is not null, to kind of get it working again. I know. I mean, I'm 2/3 down under the presentation. I'm thinking, why did they even invent this thing, right? It's just bad news all around. Sometimes it feels, but as I said in the beginning, it's a need. We have a need to represent unknown values that are not applicable. Null is a good way of doing that, but as application developers, we have to remember they're there unless there's a not null constraint. And we have to specifically plan for them when we're writing our queries. And certain things like a not in query and an in query are just ripe for this kind of confusion, because you're doing a query and it could generate an outer join. Maybe you have an outer join in the query, so then some of the fields will be null. How do you want those to behave? Right? It gets very, very tricky. Questions? Yes, sir. I'm sorry, say this again, 15.2? Yes, I'm not, okay, so let me repeat the question. So what he's basically saying in Postgres 15, which is coming out in September, October, which we're going to talk about tomorrow, and I'm not going to cover it here just because it's not out yet, right? When you create an index, and I'm going to show you this in a couple slides, you can have multiple nulls in an index. And what that does, it's a parameter that allows you to basically say, I only want one null in an index. And I'll show you that later. Doesn't really relate to where we are here, because here we're talking queries. That's more talking about an index and index creation. And it was specifically added for compatibility with other systems that some of them have that behavior. Yeah, good point. Other questions? Okay. So let's get a little more interesting here. So now we have our inc test table, 30, 40, null, and I'm going to be more specific. So here is where I'll say select where column is null, and I get my null out, right? We're here, right? And then down here I said is not null, and I get my column here. So if you want to split your table between nulls and not nulls, this is the classic way of doing it. Another thing that I think is real powerful, and I'm kind of excited about, although it's kind of awkward looking, but it's a way of doing a comparison that kind of papers over the null problem. I guess we can thank the SQL Standards Committee for this, but remember how we have like is null and is not null, and that's how you're supposed to do null comparisons. Well, there's this comparison called is distinct from. Yeah, it's verbose. I'm not a super fan of it, but it's basically saying, it's basically taking our three-valued logic for null comparisons and mapping it down to true and false. Okay, it's effectively like a funnel. It's kind of taking that null out here, and it's effectively mapping it into false. That's how I think of it. But it's doing it at least in a way that's clear to the user because they can see. So it's sort of like if you understand the weird behaviors of null and then you see this is distinct from, you know those behaviors have kind of gone away. That's how in my understanding, I think of it. So here I say, is 2 distinct from 1? Absolutely, right? No question that's true. The next one is actually a surprising answer. Is null distinct from 1? Now, if you say it's unknown, is it distinct from 1? We don't know if it's distinct from 1. Well, maybe we can go back to that old confusion that we had early on. But distinct basically says, you know, we're not going there. An unknown value in 1, in terms of being distinct, it's not a literal 1. That's how only way I can think of it. So null is not a literal 1. It's distinct from a literal 1. It could be 1, but it's not 1 now. So it gets a false. Or it gets a true. Okay. And then is distinct null, is distinct from null. That actually generates a false, so the nulls actually equal each other. In this case, null is distinct from, and there's also not distinct from, which does the opposite. So again, if you want to bring your null, instead of using is not null, if you want to map your nulls down to a true and false space, that's what is distinct from and is not distinct from does for you. Okay. So for example, at the bottom I say is, remember we still, if we do the comparison ourselves of not equal, we get null, but if we use this is distinct from, then we actually get what we would think of as a 2-valued logic with our nulls. Okay. And we can use this in queries. So for example, this is kind of interesting, and it actually does what we want. And this is, it's somewhat exciting in the world of nulls. We actually have a clause which takes a null and some other values and splits them up in a way that actually is, in two pieces, right? Not 3. So here we say, give me all the rows that are distinct from 30, and we get the 40 and the null. Remember, there's 3 rows. So we get the 40 and the null because both of those are distinct from 30. And if we say not distinct from 30, we get the 30, right? So this is kind of nice, supporting all versions of Postgres, supported. This is kind of good. I mean, it's a little verbose, but it takes a while to get used to, because is distinct from is really is not equal to, in my, right? I mean, that's kind of what it is. It's a little awkward, because when you say is, anyway, normally okay, is distinct from, which doesn't have the word not in it, is not equal to, okay? And is not distinct from, which has the word not in it, is equal to. Everyone get that? Okay? I'm not happy about that. I'm not going to be singing the praises of that, but that's what we have, okay? I would love it if it was the other way around, but again, we have to follow the SQL standard. Here's another example. This is kind of interesting, where we actually compare the first column to the second column. So we have 1 and 1, 2 and 3, and null, and we say select star from this, where is not distinct from y. Remember, a null is not distinct from another null, right? So we actually get this row and that row because they're both not distinct from each other. This is really useful for joins. If you're joining and you want to join two null columns that have match, this is gold, right? Okay. Any questions? Anyone want to run away? There we go. Okay. Here we have another example where we actually have a bunch of values, a null, a 2, a 1, and a null. And we're going to basically order them by their values. And you can see that the order by automatically groups the nulls together. They aren't technically equal to each other, but they go to the same place in the ordering, right? I mean, I guess in some philosophical way they should randomly appear in the table, but we're not going to do that. The SQL standard doesn't really want us to do that, and I don't think there's any value to it, but it would be kind of interesting to sort of guarantee we really don't know where the value is. We don't even know where it would show up in the table. No, but we don't do that. We don't do that. So they appear at the end. They're effectively treated equal for ordering purposes, meaning they show up together. Yes, sir. If I did it with a union instead of a union all, I get one null. I think so. Somebody can try it for me, please. I'm going to go on my union all rant right now. There's an argument that I think is valid that says that you should add keywords to do more work, and you should instead of less work. And the union all does not follow that. Well, because the union all will not remove distincts, and the union will remove distincts. Now, there's some set theory reasons that union all is required, but as an application programmer, when I used to do union, I would basically, every time I wrote the word union, I would write the word all unless I had a reason not to. And that catches a lot of people too. When you, the classic case is somebody does a union between two queries, and then the results don't add up because two customers have the same balance, and you do a sum on it, and you're like, what? It doesn't match, right? The battle scars I have from closing, from monthly closings. But yeah, so that's why a union all is kind of. I believe that somebody will have to test it. Select null, union, select null. See what you get. Somebody can raise their hand when they have the answer. Thank you. One other thing you can do is you can put the nulls first if you want. We have a clause here, nulls first, and it'll put it toward the front instead of the back in case you want the ordering to be different. Indexes, and Dave Stokes already talked about that, something coming PG-15, but by default, nulls are not treated equal. And therefore, if you create a unique index, we can have as many nulls as we want. but we do have a setting in PG15 which changes that. As you can see, I inserted 2 nulls into that table, even though we had a unique index on the column. The system had no trouble doing that for me. Okay. The use case for so the question is there a use case for having a single null on the table? There are some database products which only allow a single null in an index, a unique index, and some applications rely on that behavior. Now, there's a way of simulating that in Postgres by creating an index only on the null value. Like you can like do a distinct on or something, and there's a way of getting around it. But the easier way is just to use Postgres 15 and just set it when you create the index. Yeah. So yeah, there's some applications that rely on I have a table and I only want to have 1 null in that table. I don't know why. Nobody's ever explained to me. Yes. Thank you so much. Select null, union, select null returns 1 null. Thank you so much. Yeah, so select distinct also will return 1 null even if they're multiple. Thank you so much. Appreciate for that research. Other questions? Okay. Come on in, kids. We're talking about nulls. You're going to love it. We're just saying hi, and we're glad you're here. There you go. Feel free to come in or not. You're good. Appreciate you here. I always used to bring my kids to all these events, so they got to meet everybody. We loved it. Okay. Finally, I want to talk about some of the more esoteric examples of nulls, and I think this is again good to know. First one is aggregates, so nulls and aggregates. So I'm going to create a table called ag test, and I'm going to insert three rows, 7, an 8, and a null. Great. And here I do a query right up here, and you can first see the 2 red markers right away are different. And this is pretty standard SQL. If you say count star, it's just going to tell you how many rows you have, right? Makes sense. If you say count and a column name, it'll count how many non-null rows you have, right? So if you're trying to count the number of non-null rows, that's a really great way of doing it. Sum and min and max, as you can see, actually do not pretend the null row doesn't exist, right? The sum is 15, right? We just ignore the... Now, remember, if we had added these up literally, it would be null. Okay? Yeah, like what? Right? Because remember, if we took 7 and plus 8 plus null, the result is null. But for aggregates, we're in another world, right? So we get the 7, the 8, and the 15, which kind of makes sense. The average is where things kind of go wacky, right? Because I can understand, okay, this 15, you ignore the null, right? And the 7 is the min, okay, 8's the max, got it. But the average, it pretends there's 2 rows. It's like the third row just doesn't exist, right? And that's just the way average works. Just live with it. That's what the SQL standard decided for. Another bizarre, interesting, kind of cool outcome is if you delete all your rows and you run the query again, right? You get 0 for select star, makes sense. Select count x makes sense, 0. Sum is null, not 0. What? Right? There's no rows. There's no sum. It's 0. But no, we're going to get a null out of this. That can bite you pretty badly, right? You might do a query. Is the sum 0 or not? Right? Maybe, maybe not. Min and max works perfectly. Average, I like those. The sum of the 0 rows is where I start to lose it. Group by is kind of interesting because all of a sudden we're treating the nulls as equal to each other. right? We proved. Remember how I showed that, like, you add a null to something and you get a null, but for some reason when we do a group by, all of a sudden we're in a different world and the nulls are now equal to each other. So we have 2 null rows, and obviously the count is 0 because they're null, but again, you get that result. It would have been kind of cool if count of x returned null, but it returns 0. Right? It is what it is. I'm sorry this is a little smaller, but I had to get all on one slide. Another thing that comes to your rescue, particularly for strings, is coalesce. Coalesce, and I know I'm going through this. We've only got 50 minutes. I'm doing my best, but you may want to come back to these slides. I'm just saying, sometimes when I have to get down and dirty with nulls again, I have to go back and remind myself, oh, it's this for this and it's that for that. And so just be aware that don't feel bad if you feel you have to go back and look. It's not, you don't lose any points, right? So coalesce allows me to map a null to a specific value. So for example, I can map, and it's not just strings. I'm giving strings as an example, but here I'm coalescing null to 0, okay, which is great. So now my null, so if you have a query and you know a column might have a null in it, you can just use coalesce. You say, just give me the value, but if it's null, give me 0. Or give me I am null. Or give me NA, right? Here's an example of a query where I basically have a null column and I say, if it's null, just call it NA, and I get a nice NA there. Like, kind of nice. Right? If I'm doing concatenation and I think I might have a null, just make a 0-length string. Beautiful, right? Same thing down here, right? If it's a sum, this is the classic. This is how you get out of that sum problem, right? If the sum is null because there's no rows and I want a 0, that's what you got to do, right? I wish it was just like one button I could tell you to press to get nulls to work the way you wanted to, but it ends up being this crazy grab bag of just like stuff. And that's what we've gotten from the SQL standard. I don't know if I could have done any better. So it is what it is. You can go the opposite way. So you can say you can say null if, which means if the string is an NA, make it a null. That's what you have right up here. So you can see the NA that I inserted up here is now coming out as a null. Right? And this is the combination. We're coalescing null to NA, and then we're making it null again. We're going back. So that's like a loop we've gone around, out and around again. Nulls and arrays. So if the value of an array is null, and you say is null, you get true, because it's a null array. Right? The value is null. But if the array is empty, and you say is that null, it's false. And if you have a null in the array, it's also false. Okay? Remember, this is a null value, and this is a null inside an array. Row expressions, this is kind of interesting. If a row, this is very Postgres specific. If a row is if an empty row is null, yes it is. Is a row with a null in it null? Yes it is. And are 2 nulls a null? Yes it is. Right. When you mix stuff up, it gets a little more confusing. So a row and a null, is that null? No, because there's values in it, right? If it's a null and a 1, is it not null? Also, it's not true because there's stuff there. And obviously, a 1 or true, is it not null? Yes, it is. So again, it's really hard to explain. Like it is a null, false, and it is not a null. It's also false, right? Like, figure that one out. Finally, queries in the target list. You don't probably use this very much, but if a query in the target list returns no rows, it actually returns a null right there. So my select from empty test returns null. So that value of a non-query is null. Kind of cool. And I can check it to see if it's null. In fact, it is. It says true. Okay. This is the conclusion. This is I think it'll make sense to you. And I'm just going to read this. This is from Jeff Davis. I don't think he's coming, but he's one of our Postgres contributors. He says, oh, that makes sense. When you see individual behaviors of null, they look systematic, and your brain quickly sees a pattern and extrapolates what might happen in other situations. This is everybody, right? Often, that extrapolation is wrong, because null semantics are a mix of behaviors. I think the best way to think about null is as a Frankenstein monster of several philosophies and systems stitched together by a series of special cases. And I think I've shown that here today. That's why nulls trip people up, because you just see different behaviors that are not necessarily consistent. I don't know why it was done that way, but it's probably not going to change, and we just have to learn to use it. And hopefully this talk has given you a little more strength to understand when you might get into trouble with nulls. Okay? So thank you very much. And I am out of time, so I appreciate it. I can take one question, I guess, or you can just come up and ask me questions. So thanks very much. Appreciate it.